So now we're going to be talking about a keyword in C++ called const. The const keyword comes from the word constant. And what that means is that a variable that is constant should never be changed. So how this works in C++ is that any variable that you mark as const is going to be unmodifiable. The compiler will enforce that that variable can't be changed anywhere in the program. So let's look at an example. So we put the const keyword in front of the data type. So we have const int x, and we're assigning this variable x to the value 5. So try and guess if this x++ line would compile. So if you didn't know, x++ is an increment. It's equivalent to x equals x plus 1. We're trying to add 1 to x. But what happens when the compiler looks at this line of code after it sees that x has been marked const? So this won't compile because const means that x should not be changed after it's been declared and initialized. So it's already been set to 5, so we can't add 1 to it. The compiler is going to get mad because you're trying to modify a const variable. So try and guess for this line of code. We're creating the variable x. We're saying to the compiler, hey, this is a constant, but we're not setting it any initial value. This actually doesn't compile either. And the reason for that is C++ wants you to make sure that you initialize your variables when you declare them if you're marking them as const. This is just to make sure that if later on in your program you tried assigning x to something, the compiler would kind of be confused and be like, hey, you're trying to set this x variable something to some value later on in the program, but it's been marked as const, and those assignments shouldn't be allowed. So in general, if you're going to make a constant variable, you're going to have to initialize it to a value when you're declaring it. Usually this is going to be something like, say, if you're declaring a constant variable pi and you're setting it equal to 3.1415, you should be doing that when you initialize the variable pi. Wherever you declare that variable, that's where you should be setting its constant value. It wouldn't really make sense to declare pi and then set its value somewhere later on in the program. So that's something that should be done when you're declaring the new variable. So if we look back to this findMax function that we saw earlier, we were able to pass a vector in by reference, which meant that we're not making a copy of the vector when we're passing it in. We're able to refer back to the original vector. And if you think about what this findMax function should do, we can kind of tell from the name that it should be returning the maximum value in the vector. But I don't think I would expect that this findMax function should make any change to the original vector. Like say if findMax, I pass it a vector, say containing 1, 2, 3, 4, 5, I would expect it to return 5, but I wouldn't really expect it to say remove a variable or an element within that vector, or I wouldn't expect it to modify an element in that vector or to add a new element into the vector. So in computer science, we call functions that shouldn't make modifications to their arguments as non-destructive functions. Non-destructive means that that function doesn't destroy or modify its original input. On the other hand, destructive functions can make changes to the input that is passed in. So in this case, we don't want findMax to modify the contents of the original vector. So how do we prevent findMax from making an unintended change to nums? So what we can do is use the const keyword. Since we don't want findMax to modify the original vector, but we want to pass in a reference to the original vector to avoid a potentially expensive copy, we can put the const keyword before the data type. So in this case, the vector of ints, that is our data type, we put const before that. And what this does is it tells the compiler to enforce that this variable that is marked const can't be modified or reassigned. So that guarantees that this vector won't be modified within this function since it's been marked const. And if you remember from before, since we're using the ampersand to indicate that we're passing this vector in by reference, we still have the time and space efficiency benefits since we're not making a copy of the vector before calling findMax. So another usage of the const keyword in C++ is when it's specified in member functions. So when we use the const keyword in a function in a class, it means that the compiler will enforce that it doesn't make any changes to member variables in the class. So what is okay is for that function to access or read member variables of that class. But if the member function is marked const, then the compiler will get mad if you try to mutate or modify a member variable from within it. So if we look at our volunteer class from the worksheet as an example, we have this name function which we specified as const by putting the const keyword after the function name and parameter list. So after the parentheses, but before the opening curly brace. What that means is that the name function is an accessor function. It only returns the name member variable. And because it's an accessor function, it only reads from or accesses the member variable name within this class. And it doesn't make any modification to it. And since within this function, there's no modification happening to any member variables within this class, we can mark it as a const function. So this name function is a const function, meaning that the compiler will get mad if it tries to mutate or modify a member variable within this class. So this is kind of a safety net, adding this const keyword here. It's a safety net so that in the future, if someone were to make a change to any of our const member functions, the compiler will try and catch and enforce that nobody tries to make a modification to any of the member variables within the class. So it's kind of our safety net to make sure that it will error if a modification is being performed within a function that shouldn't be destructive.